Hi! In this video I want to talk about something interesting that I found once I was navigating onto a Discord server and someone asked a question like their code was doing the first request they were doing to another server was taking too long, and then the subsequent requests go faster, and like the person wanted to know if there was something that it could do to improve on this code, and it was using Java and Apache HttpClient version 4. So then we were discussing, and then we got to a nice solution by the time, I would say, using the lib and just improving onto some bits of the code and some configuration. And I wanted to make this video just to show you what we went through. Of course it's not the same scenario that we had on the question, but I tried to reproduce and go through some steps so you can get an understanding of our line of thought and how we can improve and what we can do to improve. And some approaches we will go through in this video is like the first one is like a default HTTP client, and with these we will just create it and make some requests with it in the simplest way possible, and then we will use an improved HTTP client. And this we won't use a different implementation of the HTTP client or make any configuration changes. We will just move a part of the code, and we'll see that we get a slight improvement there, which is very nice. And then we will take a look at how we set up a connection pool. So we have as well improvements on for us managing the connection pool, and then a multi-threaded approach. So we can take a look on how to do this as well, and if it improves or not the time it takes for our requests to finish. So let's take a look at the code. So here, this is the default client. This is the first approach. So going very quick through it. It's like it has a main function that I start a timer, and then here I have a for loop that will go through some URIs that I will make the request to. There's the execute request method, which is kind of the really important one, and then I finish the timer and just mark the total time. And then the execute request, it also starts a timer, and then I create a HTTP get object and create an HTTP client and execute a request to the URI that I passed to this method, and then finish the timer. So in here, this URIs you get, basically I have 4 URIs. These URIs, they come from a JSON server that I have started here. So this JSON server basically contains these 4 resources, but it's only one server. So I will make all those requests to the same server, and it's local. So keep that in mind. In this JSON server, I have a delay function, a delay middleware that I can add some latency to it. But for this case, I won't be using this functionality. I'll just make the requests, and they will go as fast as possible, all local calls. So first, let's execute this default client, and let's take a look on how it performs. Nice. So the default client just stopped executing, and we can see here that the first request took like almost 7 seconds, and then it went down a little bit, but basically 6 to 7 seconds. The first one, it seems to usually take longer on the other ones as well. I would say it probably starts a lot of objects under the hood and sets up the basis for the other requests to go, so usually it takes longer. So this one in total took 24, almost 25 seconds to execute 4,000 requests with this implementation. So yeah, let's take a look on how we can improve this implementation just by changing some parts of the code. And I left this these tabs here so we can take a look and compare the execution times. So let's take a look now at the improved default client. So the structure here is basically the same. I start a timer and then I have my execute request, but if we compare to the default client, in this default client I was creating a new HTTP client every time I make a request. So in here I was doing 1,000 at a time. So for each URL that I was trying to get, I made 1,000 requests, so I was creating 1,000 HTTP clients. And this is one of the reasons why we got that time. So what we can do to improve is, instead of executing the instead of creating the client every time we want to execute, we can actually create the client before and then pass it in to the method which will perform the request to the URL that you want to call, and then you can reuse this HTTP client in the requests. So this actually improves a little bit, and I didn't make that much changes. I wasn't going through different HTTP client. You can see I'm still using the create default. I'm not doing any changes using different builders and stuff, and this one actually improves a little bit on our code. So let's take a look and execute the improved client as well. Great. So the improved client stopped executing as well, and in here we can see that it took 21 seconds. Let's compare to the default one. So the default was 24, almost 25, and in here it was 21. So we can see a slight improvement already just by changing the where we create the client. And of course this implies that we are not creating for 1,000 HTTP client objects as well. So this improvement is a nice thing to do, and we didn't even go kind of deep into the lib. So this is nice. Now let's take a look onto the connection pool client. And with this implementation, what I wanted to do here is create this connection manager. So I wanted to have how many connections the lib would create for me in my control. So I would like to say, hey, create this amount of connections so I can use in my HTTP clients. So in here, the difference between this and the previous code is just that before executing the requests, I create this polling HTTP client connection manager. So I would like to say, I want to say to him, like, create to me a total of 40 connections, and per route I want to create a max of 10. So if you remember the URIs that I had here in my JSON server, which is db.json, so I only had 4, I have like this 4 resources that I want to call, but they come in the same URI, so they are using the same route, because the route is all this path from the protocol and the IP or the name and the port. So I can reuse these connections because I'm making requests to the same route, so it improves a little bit onto the subsequent requests as well. So let's see if it makes some difference on the requests by calling the connection, using the connection pool client. Alright, the connection pool client stopped executing as well, and here we can see that there is not that much improvement on what we had on the improved default client that I called. Like, it's a slight improvement, but it's not that much. So by managing the connection ourselves, it didn't pay out that much in this case. So it's it's more, in this case, it's more of a matter of if you want to manage the connections and if there is some other configuration here that you can use, or if you're actually making a lot of calls to the same route as I did here, to the same route, not route, sorry, the same route as I did here. So these configurations might do some difference for you. So this is something to keep in mind. But since this didn't improve that much, let's take a look at the last client that uses a multi-threaded approach. Alright, this is the multi-threaded client. This is a little different of the previous one. The code is more complex in a sense, because here we also create our pooling HTTP client connection manager that we had from the connection pool, and we'll see why in a bit. And here we also create our HTTP client before making the requests, but the major difference here is that we create this get request thread object that we'll get to it in a moment. So but basically it's an object that I will create to handle the threads, and I will create 4, so each URL that I have will have a dedicated thread to execute the requests to it. And in here I create the get requests, the get request object, and I assign a thread to this get object. Like I said, I want each thread to make a request to a URI, and then here I start all the threads, so this will call the run method on the threads. And in this case I want to wait for all the threads to finish executing, and then I want to continue my program. So I will wait for all the threads to finish to then continue, just for the sake of I want to see the how long did it take, and also I don't have any other kind of control that I can join these threads afterwards. So I need this in order for the program to wait for this. And here I have this get request thread. It's just a class that extends a thread, but it receives the HTTP client and the HTTP get object, which is everything it needs to execute and to make a get request to it. And in here I will just do the same. I'll do a for loop and go to 1,000 requests, but in this case each thread will do 1,000 requests. So the requests are now divided into threads. So let's take a look into this one and see if it improves our code and how. Yeah, so the difference we can see right at the beginning is that all the 4 URIs are called at the same time, different than the other ones where we had like the first one started sending 1,000 requests, and then the next one started, and then and goes on and on. And in here, by the way we implemented there, all the 4 URIs, all the requests start at the same time, because as you can see here, each URI is handled by a different thread. So the threads, they took longer to execute the requests in the time of the requests going. Like if we take a look at the connection pool one, like the request for 1,000 requests, it took 5 seconds, and here it took 10 seconds. But since all of those were executed at the same time, the total request, it's the time basically of the bigger thread, so to say, but they are very close, so it made no difference. But it took basically half the time of the other approaches, which is already very good. And this is you need to configure, of course, on how much threads you are able to use depending on your CPU, but this is already a nice improvement just by using this first approach. But let's see how we can improve even further, because as I said, we are using this polling HTTP connection manager still, and there's actually something we can do here that we already did on the previous one, but here it will make more difference, which is in here, if we want to set the default max, the amount of connections that we want to use per route, and the max total that we can use in general, by using this approach, the threads they make a better use, so to say, than the previous implementation, the connection pool one. So if we execute it like this, since we are making all those requests to the same route, these threads, they will get a better usage of it. So let's execute this once again, and then we can take a look on how it goes. So let's execute in a different tab, and let's compare the two multi-threaded calls. Yeah, so the first one, all the threads took 10 seconds to execute, but in this case all the threads took around 6 seconds. So this was a nice improvement that we can do just by setting those two configurations that didn't make that much difference here on the connection pool client. So from the improved default to the connection pool client, it was kind of the same, but when we use this configuration using the multi-threaded environment, multi-threaded approach, then we get a nice boost on our connections and our request speed. So this is something you can do, something you can look for if you if of course here I'm making 4,000 requests. Maybe this is a scenario you have, maybe not, but some of these improvements can actually help you and improve just a little bit on your code, but maybe it's enough for you. I don't know, it depends on your scenario. So I'll leave the link for this code below in the description so you can take a look at it, and let me know if these configs, let me know if you knew about them, let me know if there is something different that we can set on those configurations to make it even faster, to tune it up, to make it even better, and let me know what you think in the comments, and I'll see you in the next one. Bye.